Okay everyone, this is the tool that many of you are going to learn to use because it's just too good to pass up. I am going to start back where you would start, which is just knowing a couple of keywords. This is where we're going to go, which is into some code, www.google.com. Whether or not you ever use SketchUp, bookmark this one, Google Ruby API. Right here you have lots of information regarding the kind of the background of using the programming scripting language Ruby, which is like Python, which is used a lot in geospatial and lots of other things. You go to the docs here and you essentially have a bunch of documentation, and all we're looking at is doing a simple latitude, longitude to universal transverse Mercator coordinates. So we're going to click on the lat long, and it's going to give us a set of methods that we can use for data here. And so there's really not many on the lat long, and actually all we really want to do is a lat long to UTM. So there it is there. So we realize that if we put our latitude and longitude into that format, it's going to give us those coordinates in UTM. So we're going to go ahead and just learn to pull. I'm going to right click here and copy, and bookmark this. You're going to come back to that, but looking at that format, it's not too bad to know what this is saying is first define by decimal latitude longitude, realizing that often your latitude will be a positive number and your longitude will be negative. So I don't think this is a great example. So your longitude, the latitude are the things that go up like ladders, and we're at about minus 90 longitude. So we're going to see what comes up with this. As you hear the dog in the background. So that all said, now I'm going to kind of close this out. Hopefully it saved that. I'm going to go into your basic old SketchUp. No. I'm going to start using SketchUp here, and you're going to do SketchUp even if you don't use it to draft. You're going to use it for the Ruby app that's underneath. So I'm going to go here to plugins, Ruby code editor, something like that, and to bring this up here, I'm just going to now go ahead and place that code here. And what that's doing is it's defining a couple of things here. We'll see whether this works. And then I'm just going to say this, the final statement, put screen UTM dot to string. We'll see whether that works. It might be to array. So I'm going to just try that, to array. And then I'm going to plug in, turn on one other little output window here. And I'm going to run that and see what I get. And you see that it returned that this is the 48th UTM zone, and then an X and a Y. I think those are, or they might be Y and X. And so let's just think about what ours is. Pretty close. We're 45.00, and we're pretty close, not exactly, to around minus 90. In other words, we're back behind the back of, or a quarter away around the world from, Greenwich, if you would, and halfway up the world from the equator to the North Pole. Once again, run this, and you see that we are in UTM 16. So that's what I'm going to do in terms of converting lat long to X and Y UTM 16. You just have to realize that sometimes you're counting in computing in angles, which is what latitude longitude is, and sometimes you're counting and keeping track in X's and Y's, which is what UTM coordinates are. For the most part, we'll be using just simple coordinates down in the inches and millimeters array, but we'll want to be cognizant of just coordinates are coordinates, and that's why we're looking to the stars. Incredibly succinct, fast, great, wonderful, and then the beautiful part about this, it will do the drafting for you. But why do that when you can use Hans Rosling's incredible engine available on Google Gapminder? thanks for listening.